All right, let's dive into the fascinating world of clouds and their composition. Clouds are not just fluffy white things in the sky, they actually consist of various tiny particles suspended in the atmosphere. These particles include water droplets, ice crystals, and even small dust particles. Water droplets are formed when water vapor in the air condenses onto these small particles, like dust or pollen. This process occurs when the air containing water vapor cools down to its dew point, which is the temperature at which air becomes saturated with moisture. Once the dew point is reached, the water vapor in the air starts to condense and forms tiny water droplets. Now, ice crystals are another component found in clouds, especially in colder, higher altitude clouds such as cirrus or cirrostratus. These ice crystals are formed when the temperature in the cloud drops below freezing, causing the water droplets to freeze. The ice crystals can then grow in size as more water droplets freeze onto them. In addition to water droplets and ice crystals, clouds also contain other small particles like dust, pollen, and even pollutants. These particles act as nuclei or starting points for the condensation of water vapor. So, in a way, clouds are a collection of tiny water droplets and ice crystals that have clung to these small particles suspended in the atmosphere. As a result, clouds can appear in various shapes, sizes, and colors depending on the type of particles they contain and the atmospheric conditions. In the next section, we'll explore the different types of clouds and their characteristics. Now that we have a better understanding of what clouds are made of, let's explore the various types of clouds and their characteristics. Clouds are classified into different types based on their appearance, altitude, and the atmospheric conditions in which they form. The three main types of clouds that you've probably heard of are cumulus, stratus, and cirrus. First, let's talk about cumulus clouds. These clouds are often described as the cotton ball or cauliflower-shaped clouds. Cumulus clouds are characterized by their puffy, rounded appearance and are typically found at lower altitudes. They form when warm air rises and cools, causing the water vapor in the air to condense into water droplets. Cumulus clouds are generally associated with fair weather, but they can grow into larger, towering cumulonimbus clouds, which are responsible for thunderstorms and heavy rain. Next, we have stratus clouds. Stratus clouds are flat, gray, and featureless, often resembling a blanket covering the sky. They form at low altitudes when a large mass of air is lifted and cooled, typically due to the presence of a cold front or an area of low pressure. Stratus clouds can produce light rain or drizzle and are often associated with overcast or gloomy weather. Lastly, let's discuss cirrus clouds. Cirrus clouds are wispy, feathery clouds that form at high altitudes, usually above 20,000 feet. They are composed primarily of ice crystals due to the colder temperatures at such high elevations. Cirrus clouds are often associated with fair weather, but their presence can also indicate an approaching warm front or a change in weather conditions. In addition to these main types, there are also various subtypes and combinations of clouds, such as alstratus, alticumulus, and nimbostratus, each with their own unique characteristics and appearance. Understanding the different types of clouds and their characteristics can help us predict weather patterns and better comprehend the atmospheric processes at play. In the next section, we'll delve deeper into the atmospheric processes that lead to cloud formation, including condensation, evaporation, and the role of temperature and humidity. Now that we've explored the different types of clouds and their characteristics, let's dive into the atmospheric processes that lead to cloud formation. The formation of clouds involves several key concepts, including condensation, evaporation, and the roles of temperature and humidity. Condensation is the process by which water vapor in the air turns into liquid water droplets or ice crystals. This occurs when the air cools down to its dew point, which is the temperature at which air becomes saturated with moisture. When air reaches its dew point, the water vapor in the air starts to condense around small particles like dust, pollen, or pollutants. These particles act as condensation nuclei, providing a surface for water droplets to cling to, eventually forming a cloud. Evaporation, on the other hand, is the process by which liquid water turns into water vapor. This occurs when water molecules gain enough energy, usually from the sun or other heat sources, to escape the surface of the liquid and become airborne. Evaporation plays a crucial role in the water cycle as it replenishes the atmosphere with water vapor, which can later condense to form clouds. Temperature and humidity are key factors in the formation of clouds. As warm air rises, it cools and expands, which lowers the air pressure. When the air pressure drops, the air's ability to hold water vapor decreases, and the dew point is reached more quickly. This is why clouds often form as warm air rises and cools. Humidity, which is a measure of the amount of water vapor in the air, also plays a significant role. When humidity is high, there is more water vapor available for condensation, making it easier for clouds to form. In summary, the atmospheric processes that lead to cloud formation involve a delicate balance between condensation, evaporation, temperature, and humidity. These factors work together to create the diverse array of clouds that we see in the sky. In the next section, we'll examine the role of clouds in weather patterns, including their impact on precipitation, temperature regulation, and storm formation. Now that we've discussed cloud formation and the atmospheric processes involved, let's examine the role of clouds in weather patterns. Clouds play a significant role in the Earth's weather systems, affecting precipitation, temperature regulation, and storm formation. Starting with precipitation, clouds are the primary source of rain, snow, sleet, and hail. As we've learned, clouds are made up of water droplets and ice crystals. When these droplets or crystals grow large enough, they can no longer be supported by the surrounding air and begin to fall to the ground as precipitation. The type of precipitation that reaches the ground depends on the temperature and atmospheric conditions between the cloud and the Earth's surface. Temperature regulation is another important role of clouds in weather patterns. Clouds can both cool and warm the Earth's surface, depending on their type and location. During the day, clouds can reflect sunlight back into space, preventing some of the sun's energy from reaching the Earth's surface, resulting in a cooling effect. At night, however, clouds can act as a blanket, trapping heat near the surface and preventing it from escaping back into space. This results in a warming effect. The overall impact of clouds on temperature regulation depends on a complex interplay between their altitude, thickness, and the time of day. Lastly, clouds play a crucial role in the formation of storms. Thunderstorms, for example, are associated with towering cumulonimbus clouds. These clouds form when moist warm air rises rapidly and cools, causing water vapor to condense and release latent heat. This heat release fuels the storm's growth, leading to strong updrafts, downdrafts, and eventually precipitation in the form of heavy rain, hail, or even tornadoes. In summary, clouds are essential components of the Earth's weather systems, influencing precipitation, temperature regulation, and storm formation. They are not only fascinating to observe, but also play a vital role in shaping the weather patterns that affect our daily lives. In the next section, we'll learn about the importance of clouds in Earth's climate system, including their role in reflecting sunlight and their contribution to the greenhouse effect. As we wrap up our discussion on clouds, it's important to understand their role in Earth's climate system. Clouds have a significant impact on our planet's climate, mainly through their ability to reflect sunlight and their contribution to the greenhouse effect. First, let's look at the role of clouds in reflecting sunlight. Clouds can reflect a portion of the sun's energy back into space, reducing the amount of solar radiation that reaches the Earth's surface. This process, known as albedo, can have a cooling effect on the planet. The amount of sunlight reflected by clouds depends on factors such as their altitude, thickness, and composition. High-altitude clouds, like cirrus clouds, tend to have a lower albedo and allow more sunlight to pass through, while low-altitude clouds, like stratus clouds, have a higher albedo and reflect more sunlight back into space. Now let's discuss the greenhouse effect and how clouds contribute to it. The greenhouse effect is a natural process that occurs when certain gases in the Earth's atmosphere, such as water vapor, carbon dioxide, and methane, trap heat by absorbing infrared radiation emitted by the Earth's surface. This trapped heat warms the planet and helps maintain a stable climate that can support life. Clouds can both enhance and mitigate the greenhouse effect. On one hand, clouds can trap heat near the Earth's surface, similar to greenhouse gases, and contribute to warming the planet. On the other hand, by reflecting sunlight, clouds can also help to cool the Earth, counteracting some of the warming effects of greenhouse gases. The overall impact of clouds on Earth's climate system depends on a complex interplay of factors, such as their type, altitude, and location. As our understanding of clouds and their interactions with the climate system improves, scientists are better able to predict and model future climate changes and develop strategies for addressing global warming and other climate-related challenges. In conclusion, clouds play a vital role in Earth's climate system, both by reflecting sunlight and contributing to the greenhouse effect. Understanding the composition, types, and atmospheric processes that lead to cloud formation is essential for better grasping our impact on weather patterns and the planet's climate as a whole.